2024 was a big year for RFID growth in tagging, growth in adoption, and growth in use case generated value. Last year at the show, we introduced loss detection, which is using RFID to find the red shopper events and be able to create a set of analytics around that. This year, we're introducing how do you use that loss detection data to better fight fraudulent retail returns.
NetApp Retail is the #1 RFID solution for inventory accuracy and loss prevention. We are working in tandem with Zebra with their hardware to give data back to the retailers and make actionable insights. Whether that's from hot items, high theft hours, or peak events, we're giving them the decision to do what they want with the data. Peak events, organized retail crime coming in, taking a bunch of things running out, we're giving that back to the retailer. Sweetheartening, passing things off internally without things being paid for, walking through the exit, we're grabbing that detection as well. Loss prevention and loss detection coming together to do one.
Last year, the NRF reported $890 billion of retailer returns in the US for a total of 17% average retail return rate. Returns are a big deal for retailers to get right, but oftentimes they use outdated technology that fails to optimize the experience for the shopper. It puts too much burden on their associates in stores and warehouses to manage messy SOPs, and also fails to optimize the resale value of the returns once they're back in the retailer's possession. Optoro is a 100% returns-focused technology company. We make a returns management system to drive results for the shopper and the retailer. Returns fraud is also growing significantly. It's grown 300% over the last 4 years. And the question for retailers is, how do I deliver a great experience for my best shoppers while also including appropriate friction and protections against fraudulent shopper behavior? Here we'll look through Optoro's returns portal technology as well as store technology to deliver the best shopper experience. Let's say I bought this gray t-shirt and now I'm going to initiate my return online. I could walk back into the store without this pre-initiation, but by initiating online, the retailer can offer an accelerated returns flow in the store. The retailer also benefits from having advanced information about the return that the shopper plans to make. So here, the shopper inputs some information about their return. They'll say what their order ID is and the shipping zip code. Next, the shopper selects the item that they're planning on returning. Here, it's a gray t-shirt. Following that, they'll select the reason for the return. Now, if I were to walk into a store as a shopper, it might be a confrontational experience to have the associate ask why I wanted to do the return. Often we find associates don't ask that question at all because they don't like the friction with the shopper. But if a shopper is doing this in the comfort of their own home, they'll be more likely to give you an accurate return reason. Finally, the shopper needs to select how they're going to make the return. Optoro supports several different return methods. We want to drive people to the retailer store as the top priority, but if they prefer to use a third-party drop-off location like Happy Returns or to mail in the return, those options are supported as well. By getting the shopper to go back to the store, the retailer has a better chance at converting an upsell. We'll show the shopper a refund confirmation screen and then give them instructions specific to the return method that they chose. In this example, we'll give them a QR code that they can use inside the store at the returns kiosk. Now the shopper walks into the store and they can see a long line at checkout where they can complete their return. But because they initiated their return online and they have a QR code, they can go straight to the self-service return kiosk. They'll take the QR code, scan at the kiosk, and then they'll see the item that the system expects them to return based on their interaction with the online returns portal. I confirm, yes, this is the t-shirt I plan on returning, and next I'm instructed to drop the item into the RFID reading bin. The system reads the RFID tag, and it knows that that unique item was purchased and returned by me, as opposed to, say, some other item that was fraudulently stolen. The shopper is instructed to take the item from the bin and place it in a separate bin for the retailer to take possession of it. But let's say, instead of doing that action, I am now the bad fraudulent shopper. I scan my code, I say that I'm going to return the item that I purchased, but rather than bringing that item back with me, I go into the store, grab the same item that I haven't purchased off the shelf, and drop it into the bin. The system reads the RFID tag and knows that that item wasn't part of my purchase and wasn't purchased at all, and therefore this shopper needs to go to customer care in order to have additional assistance and to have intervention to their fraud attempt. Now the shopper interaction's done. The shopper has their refund, and the question is, what should happen to the inventory that they returned? Traditionally, retailers might train their associates to follow some simple rules and simple system interactions in order to determine, well, is this in my assortment? If so, I'll put it back on the floor. If not, maybe I'll put it on a discount section of the store. But by having these relatively simple one-size-fits-all rules, they failed to maximize the margin recovery from these returned items. With Optoro's in-store technology, associates can, in the back of the store, scan the item that was returned and receive an immediate decision about where it should be dispositioned. In this example, it should be dispositioned back to the store floor. But how did the software make that decision to return this item to floor? Behind the scenes, our smart disposition technology incorporated attributes of the product combined with rules that were set by the retailer to consider all of the different potential outcomes for the unit and decide which one is going to be optimal for that retailer. For example, the item could be returned to the floor, it could be sent back to a DC, sent to a sister store, sent to clearance, among other channels. The idea is that the associate doesn't need to make that decision. The retailer can put rules and collect attributes that can make a more granular and appropriate decision. One input for that decision-making could be data from this RFID technology itself, including the inventory positions of the various nodes that might be receiving this returned inventory.
RFID-enabled returns management provides the information to make better inventory placement decisions. It provides the data to intercept fraudulent returns and allows for retailers to create a frictionless, seamless customer return experience.